All right, we're on the back page of the study guide. I had to print a new copy, so mine is pink. Sorry about that. Question 31 says, find each of the values using the kite below. So remember what we know about kites. We know that there are two pair of consecutive congruent sides. So this shorter pair is congruent, and then this pair is congruent. And remember, consecutive means like in a row. So these two and then these two. We also know that these two angles are congruent. We know some things about the diagonals, but I'm not sure that that's really important here. We could use the diagonals. And then lastly, because it's a quadrilateral, we know it still follows this rule of like the sum of the interior angles. So I don't know why I put that in parentheses, is 180 times n minus 2. So since it has four sides, we know the sum of the interior angles will be 360. And that's going to be true for all quadrilaterals. Okay, so that's some information that we might use while solving this kite. So the first thing we're asked to do is find x. And if I look, I know that MA is congruent to AT, and I'm given expressions for both of those side lengths. So I could say 9x minus 8 is equal to 2x plus 20. Then I just subtract 2x from both sides. So 7x minus 8 equals 20. Add 8. 7x is 28. Divide by 7. X is 4. All right, next, to actually find the length of MA, all I need to do is substitute x equals 4 back into this expression. So if the length of MA is 9x minus 8, and x is 4, that's just 9 times 4 minus 8. So that is, what, 36 minus 8, which is 28. All right, so we know MA is 28. AT would also be 28. We're not asked to find that. We're next asked to find the length of TH. So we already found that x is equal to 4. Oops, sorry, smudged that answer. And we said that MH and TH are congruent. So if I can find MH, I know what TH is. And MH is 3 times x. So it's just going to be 3 times 4, or 12. So the length of side TH is also 12. All right. Then lastly, we're asked to find the measures of angle M and T. And we said earlier, in a kite, those angles are always congruent. The two angles that are opposite each other that separate the short and the long sides of the kite are always congruent angles. So we really only have one more thing to find. We know that H and A are 62 and 34 degrees respectively. So we could add those up and subtract from 180. Or, sorry, not 180, from 360. I was thinking triangle for a second. So if I add that, 62 plus 34, I get 96 degrees. And we said these four angles have to add up to 360. So if I do 360 minus 96, what I'm left with is 264 degrees. And that's not just angle M or T, but that's angles M and T combined. So since we know they have to be equal, we want to divide that by 2 to get each angle. So 264 divided by 2 is 132. So now if I were to add those up, 62 plus 132 plus 34 plus 132 again, that should all add up to 360 degrees. So the measures of angle M and angle T are each 132. Okay, moving on to 32, we have an isosceles trapezoid. Remember, we said in an isosceles trapezoid, these side lengths are congruent. The base angles, so the two at the top and the two at the bottom, because a trapezoid has two bases, those angles are congruent as well. And then these angles for all trapezoids are going to be supplementary. So A and P, and then also R and T. All right, so solving for x, again, we have our two congruent sides. So 6x plus 28 must equal 9x plus 4. Subtract 6x from both sides. That's what, 3x plus 4. Subtract 4 from both sides. 24 equals 3x. Divide by 3, x equals 8. All right, then to find the length of TR, we just plug that back in. So 6 times 8 plus 28. So let's see, so 6 times 8 is 48, and then 48 plus 28 is 76. So 76 for TR. Then we're asked to find the measure of angle A, and that's going to be the top base angle that's congruent to angle R. So angle A is 117 degrees. And then we're also asked to find the measures of angles T and P, well just P, but it's the same as T. And we said this is going to be the supplement to this top angle. So the measure of angle P is going to be 180 minus 117, and we get 63 degrees. All right, so that is our isosceles trapezoid. The very last part, in number 33, we are asked to classify the quadrilateral LION. We're given the 4 vertices. Then I'm asking you to find the length of each side and the slope of each side. The first thing I would do is graph this, and I would say be careful graphing it, or just be precise. The reason I had to print a new copy of the back page and it's pink is because I messed up graphing it the first time I tried to do it. So, all right, so the first thing I would do is I would, with a straight edge or ruler, make like an X and a Y axis, because I just gave you a graph, I didn't number it. So I'm just going to make a Y axis kind of going down the middle, and then an X axis going across. I didn't really count the squares or anything, so it's a little off center. Okay. All right. So now when we go to graph it, L is at -5, comma, -2. So at 1, 2, 3, 4, 5, 1, 2. I'm going to label that with L. Point I is at 1, comma, 2. So over 1 and up 1, 2. And point I is right there. O is at 3, comma, -1. So 1, 2, 3, -1 is point O. And then lastly, N is at -3, -5. So 1, 2, 3, 1, 2, 3, 4, 5. All right. This looks better. The first time I did this, I really messed it up. All right. So then we want to connect these. All right, and I'm just going to double check this one more time. I have a habit of messing up my graphs. So we said -5, -2. So 1, 2, 3, 4, 5, down 2. +1, +2, so that's in our first quadrant. 3, comma, -1, that's in our fourth quadrant. And then -3, -5 in our fourth quadrant again. Okay, so we are asked to classify this. And before we jump to any conclusions about what shape it is, let's make sure that we really do these other things so we can prove what shape it is mathematically. So we're going to find the lengths of LI, IO, ON, and NL, the 4 sides. All right, so as I go to find the length for LI, I'm going to go up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. So double check 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6. Okay, so we could just use the Pythagorean theorem here and do for Li that we're going to do 4 squared plus 6 squared and then take the square root. So 4 squared is 16, 6 squared is 36. We're taking the square root of that. 16 plus 36 is 52. So Li is the square root of 52, which is approximately, and I honestly don't care if you want to leave it as a radical or a decimal, but it's about 7.211. All right, so then when we go to find the length of IO, I'm going to go over 2 down 3, over 2 down 3. So if I plug that in the Pythagorean theorem, that's 2 squared plus 3 squared, then take the square root. So that's 4 plus 9, which is the square root of 13. And the square root of 13 is about 3.607, or sorry, 606. Okay. All right, so then when I go to find ON, I'm going to go down 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6. So when I get those same numbers in that triangle, I know that it's going to have the same length as Li. I'm still going to get the square root of 52, or about 7.211. And then for NL, I'm going over 2 up 3. So the same thing's happening there. That's going to be the same length, exactly the same length as IO, the square root of 13. And then if I take that square root, that's about 3.606. All right. So far, what we've proved is that this shape is a parallelogram. Because if the opposite sides are congruent, it's a parallelogram. If you're looking at it and thinking that looks like a rectangle, you might be right about that, but we need the slope to prove that it's a rectangle because we have to prove that these are right angles. So we're going to find the slope of Li, IO, ON, and NL. All right. The nice thing is that if you use the Pythagorean theorem, we can get our rise and run from these same triangles. So if you look at Li, it has positive slope. It's going up from left to right. So my slope is going to be positive 4 over positive 6 because it's my rise over my run, or my change in y over my change in x. And then 4 over 6 reduces to 2/3. So that's my slope of Li. If you look at NO, it has the same slope because we're going up 4 over 6. So NO, or ON, also has a slope of 2/3, and it's positive. IO and LN both have negative slopes. So when you take a look at those, both of those slopes are negative because from left to right, they're going down. So I could think of it as going down 3 over 2. So both of their slopes are going to be negative 3/2. All right, and then what we notice here about these slopes is kind of important. We notice that 1 or 2 segments have a slope of positive 2/3. The other 2 have a slope of negative 3/2. And that satisfies the requirement of their slopes being opposite and reciprocal. So opposite referring to the signs, reciprocals referring to two numbers that multiply to positive 1. So 2/3 and negative 3/2. Because their slopes are opposite reciprocal, what that proves is that these sides are perpendicular to each other. So now we can prove that that is a rectangle. So it's not just any old parallelogram, it's a rectangle. It's got opposite congruent sides and they're perpendicular to one another. All right, that's it.